Hello and welcome to my YouTube channel. Today, we would be looking at how to use the select statement to retrieve data. And specifically, we would be focusing on the Chinook database, which you can find on the SQLite tutorial website. Down here on the lower left-hand side of my screen, you can see the ER diagram, or what we call the entity relationship diagram for the Chinook database. You can see all the tables, right? I think we have a total of 11 tables that make up the Chinook database. And each table has the column names, which has been listed in each table. And we can also see the primary keys represented by the small keys there for each of those tables, as well as the relationships between the tables, right? There's a one-to-one, one-to-many relationship, which you can see on the table. Well, for today's exercise, we would focus on how to retrieve the data present in those tables using SQLite, right? So let's go over to Google Colab. So make sure you have your Google Colab open. And then in order to create a new Google Colab sheet, or I'm just going to say Colab sheet for short, right? You click on new and then more, and then you go to Google Collaboratory, right? It's going to create a new one for us. So what I like to do first is to just rename the file, right? So I'm just going to say then SQL .1, no, I forgot how to spell, select statement, right? So that's what I'm going to name it as. So that way, if you come back here and you refresh this, okay, so it's supposed to, let's give it a minute. Okay, so once we refresh it, you can see it here, right? We have that file in our Google Colab notebook. So it's in there now. So the first thing we want to start with is installing our packages. So I'm just going to say install the SQL packages. Right, so pip install SQL. So I think I did all of this in the previous video, right? So I'm not going to spend so much time explaining what these packages do. But if you missed that video, please search for the video called how to use SQLite on Google Colab, right? And you would see it, or basically just check on my YouTube page and you would see that where I explain each of these packages and what they help us to do. So so here I'm just going to go so I'm just going to run this quickly. All right, so just in case you see an error like this on your Python code, please do not worry about it, because we're using an older version of SQL Alchemy, right? So it's not any issues or whatsoever. So close that up and then run the next one. So here I'm just trying to mount my Google Drive. So it asks me to connect to Google Drive. I do have a pop-up box that shows on my other screen. So this is the pop-up box. So I'm just going to connect to it and then approve that, and we should be good to go. All right, so once you see it mounted at contents of Drive, we're good to go. Basically, when you click here, you would be able to see your Google Drive, right? So that's my Google Drive there, right? So remember from the last video, I showed you how to create this DB, which is called database, and we basically have our Chinook database in there. So that's where we would be retrieving our data from, or doing today's exercise from there. All right, so let's continue. We have that done. Load the database. Just trying to load the Chinook database here. So just in case you have named it something else, right? Maybe this here, you need to go into your Google Drive and check what you named it as, and make sure you use that naming convention there. All right, so the next thing I want to do is basically see all the tables that are present in my Chinook database file. So you can see I'm already using the select statement there, right? I'm not spelling this word here. All right, so let's run this. All right, so this here shows us all the different tables we have in our Chinook database, right? And you can see that it corresponds to the tables that we see on the ER diagram, right? So let's see, we have a table called albums. That's it here on the ER diagram, right? We have a table called genre. That's it here on the ER diagram, right? I think why I like to do this step here is so that I can see the naming convention of these tables, right? Is it sentence case? Is it uppercase? Is it lowercase, right? So it helps me get a sense of how the tables are basically named, so that when I start calling those tables, I'm using the right name to call those tables, right? That's why I like to basically do this step. So now let's look at the questions that we have to do in this exercise, right? So we have 3 questions, or 3 things we're trying to work on in this exercise. The first is to retrieve data with the select statement. The second is to retrieve multiple columns using one of the wildcat commands, and then also look at how we can limit the results. So sometimes you might have a database with so many tables, or you could have a table with so many columns or rows, and you just want to limit the result. Maybe you want to look at the first 5 rows, or maybe the first 10 rows, or the first 20 rows, and things like that. So we use the limit when you're looking at tables with that have very large file sizes, right? Or maybe very large rows. So that's when we use the limit command. So let's look at the first question we have there, right? Which is retrieve data with the select statement. So I'm just going to put it in the text box here. retrieve data with the select statement. Oops. All right, so, and it's asking us to search for the composers of each track, right? So that means we would be working out of this table called tracks, right? So remember percentage SQL, that allows us to bring in SQLite into Python, right? And we can do our extraction from there. So we say select, right? And under tracks, right, we're looking for composers. So let's come back here. So where's tracks? Yeah, this is tracks, and it has different columns, right? There's track ID, there's name, there's album ID, there's media type, there's genre ID, there's composer, there's millisecond, there's bytes, and there's unit price, right? And all the other things you have beside each of those columns are the data types, right? Right. Some of them are integers, some of them are numeric, some of them are characters, right? So we're looking at the composer, which consists of characters, right? So that means what we're selecting here in our select will be composer, right? So I think we can have it like this, composer. And from, we're basically now telling SQL that we need you to extract the composer from tracks, right? Because the question says, search for the composers of each track, right? So maybe let me I'm gonna put a comment. So we use the dash in SQLite to make a comment. So I'm just going to put the question, what the question is asking us to do. So question, search for the composers of each track. So we have different tracks. So if we run this, so here, okay. So here we see a list. Oof, it's a really long list, right? It's a really, really long list of all the composers, right? It's a really long list of all the composers of each track of song we have in our Chinook database, right? So you can see it. The first one was Angus Young. Then we have Boat, we have Diffie, and so on, and we have Steven Tyler, and so on and so forth, right? So that is how you retrieve data using the select statement. So we'll see more examples as we go on. So I think we can highlight this. Remember, we always highlight it as a green. So it's a green there because we're done. Maybe let's see. Let me take a lighter one. This one. Oof. Light maybe. All right. Now I highlighted what I'm not supposed to highlight. All right, so let's go to the next one. Retrieve multiple columns, right? Sometimes we just want to see, all the columns present in that table, right? So let's code, remember percentage, SQL, and then, so in order to retrieve all of those columns we have in the tracks table, because the question says, how many columns do we have in the track table, right? So just so you understand what we're doing, I'm just going to be putting each of those questions inside the Google Colab. So how many columns do we have in the track table, right? So we can see all the columns from our ER diagram here, right? But there's a command we know as or should I say a tool or a function, which is called the wildcard, right? And the SQL wildcard, which is represented by an asterisk, right, allows us to extract or retrieve all the columns we have in a particular table, right? So here I would just say, still using the select statement, right? Then that's the asterisk, right? It allows us to retrieve all columns that we have in the table. Then our from, which remember, is the table. What table are we looking at, right? From what table do you want all the columns to come from? And that is tracks, right? I hope I spelled that correctly. Yeah, tracks. Okay, so let's run this. Done, right? So you could see here, it shows us 3,500 rows of data, right? And let's see if it gives us all the columns. So we should have 1, 2, 3, 4, 5, 6. So we should have 9. We should have 9 columns. So we have track ID, we have name, we have album ID, we have media type ID, we have the genre, we have the composer, we have milliseconds, we have bytes, and we have unit price. So you can see the complete 9 columns have been extracted for us to see. And all the rows related to these 9 columns have also been extracted as well. So that's how you retrieve multiple columns using the wildcard feature, which is asterisk, right? So please take note of that. Our last exercise is asking us to limit the results, right? Remember at the start of the video, I told you all what the limit feature does in SQL, right? So now let's put it to practice. So percentage SQL, and then I'm just going to put the question there. So that is to retrieve multiple columns. I just like to name my collab very well so people understand what I'm doing. So limit the result. So what is the name of the 5th track composer? So select. So the question is, what is the name of the 5th track composer, right? So I think there are multiple ways you can do this, right? First, you could use what we did before, right? Where we decided to see all the columns, right? And you can basically just count it, right? The 5th track. So you have the track ID and you can just count 1, 2, 3, 4, 5, right? And you can see that the name of the track is Princess of the Dawn, and then the composer is Diffie, right? Diffie and R.A. Smith Diesel. Those are the composers of the track, the 5th track called Princess of the Dawn, right? That's one way you can do it, right? By viewing the entire table, all the columns in the table, right? But an easy way out to do it is to basically use the limit limit function, right? So we could just say select, and we just focus on that specific column that we're interested in, which is composer, right? From tracks, right? Then limit 5. And then the semicolon basically helps us to terminate our SQL command. So we terminate our SQL command when you use the semicolon, right? So if I run this, guess what? It's just going to focus on the column called composer and just give us the first 5 composers, right? Because that's what the question is asking for. What is the name of the 5th track composer? So it's just going to count it and give us the first 5 composers, right? And we can see here it's Diffie and R.A. Smith Diesel, right? Maybe if you want to make it a little bit fancy, right, we could decide to add, let's say the track ID, right? Let me see, how is it written? Yeah. So we could have track ID, right? We could also include their name of the song and then composer. And if we run this again, it changes, right? So you can see number 5, the name of the song is Princess of the Dawn and the composer is Diffie, right? So it just shows us the first 5 and it takes out all those other redundant columns that we do not need to answer the question. So I've showed you all multiple ways you can use the limit function on SQLite. And then also we've looked at 2 other questions as well, the multiple columns and then the select statement. And this here is also an example of multiple columns too, right? We basically retrieved more than one column, which is track ID, name, and the composer. Thank you so much for watching this video. If you haven't subscribed, please subscribe to the channel so that you can get all our updates when we post new videos. Thank you.